The microphone. Section 4142, and I am going to send a shout out to Jeff and Debbie again, so I can show this to them tonight. But my brother and sister-in-law coming to town, first time in a while, and I'm really excited about it. I'm all giddy inside. But that's that. Is that right? Yeah. No. These ones are in their mid to early 30s.
They like going to the hacienda.
Section 4-1 and 4-2 notes. Factors, monomials, and powers and exponents. So those are the two things that we're going over today. Factors are numbers that divide into a whole number with a remainder of 0. For example, 2 is a factor of 12 because 12 divided by 2 is a whole number, 6. However, 5 is not a factor of 12 because 12 divided by 5 is 2, and then there's a 2 remainder, or you'd have a decimal, or you'd have a fraction after the whole number. So you need to have a whole number, then it's a fraction. Another way of saying that 6 is a factor of 12 is to say that 12 is somebody's birthday today in here? Is somebody's, your birthday is today?
My birthday's coming up. My birthday's in April.
5 days? What's your favorite color?
Neon green.
Blue? What flavor of blue? Shh. I'm going to see if this is this visible? Can you see that? So we'd say that 12 is a 6 is a factor. Say that 12 is divisible. Yeah, divisible. I spelled that wrong. I think. Yeah, it's able. Is divisible, and you don't have a pencil. Well, I'll let you borrow one as you sign the binder for coming unprepared to class. Is that 3 yet? No, it is divisible. I second guess myself. It's not able. Yeah, I had it right the first time. I just second guessed myself. Last time I listened to a kid. Just. It's divisible by 6. There are rules to test for divisibility. This is what you guys learned last year. You learned this during the 3rd week last year in 6th grade. Okay? You knew this, you had this. This is just a reminder. If you remember these, it's amazing just how quick you can do multiplication and division. So I'm going to give you a moment or some time to write those down, those divisibility rules. Yes, sir. Ignore that and. That word that's over the and says last. Who's the baseball coach again? Okay. And Keller's the 8th grade coach then? Okay. So as you're finishing up, for those that are done, I'm just going to read them out loud. Divisibility rules. The ones digit must be divisible by 2 to be divisible by 2, and also it's just an even number. Any even number is divisible by 2. 3, the sum of the digits is divisible by 3, so that means if, I could do an example actually. Boom, 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 boom. So if I have 200 and 270, no, 3. What I would do is I'd test for divisibility by adding 2 plus 7 plus 3, which is going to be 9 plus 3, which is 12. Is 12 divisible by 3? Yeah. So that means that 273 is divisible by 3. That's what that means. Then we have 4. The number formed by the last 2 digits is divisible by 4. So that means that if I had 900 and, let's see, 48. 48 is divisible by 12, or 48 is divisible by 4 because 4 times 12. So 48 divided by 4 is 12, so that one checks out as well. Ends in, this one's really tough. Number 5, it ends, the last digit is a 0 or a 5. Watch out now. Okay, isn't it though? Oh, sorry, Bob. Then we have 6 if divisible by 2 and 3. So if it's even and it works with the stuff that it can add up. 10 adds in or ends in a 0. Well, let's play with these. Oops, I'm sorry. Was anybody not done? Okay. Let's see what's one page 170. Oh. Yeah. Right there. Let's play with these. So we're going to go through this little checklist here to check to see if we got 111. Is that divisible? We're checking to see if it's divisible by. Check to see if the number is divisible by 2, 3, 4, 5, 6, or 10. 111. So what's the rule for 2, Joe?
If the one digit is divisible by 2.
It's okay, so you can just make it much easier by saying even number. Even though they're scented, please don't do that in here. Okay? Is it an even number?
Yes.
No. So is it divisible? No, it isn't. Not 2. Okay, so actually I'm going to do this. Is it divisible by 3?
Yes.
Why?
Because all 3 of the digits add 2.
Good, because 1 plus 1 plus 1 is 3, and 3 divided by 3 is 1. How about, wait, 4. 4. Is 11 divisible by? No. So, how about 5? Is 5, what's the rule for 5, Davenport? The end is 510, and it doesn't. Okay? How about 6? Why not?
Because it's not divisible by 2 and 3.
Good. Yes, because it's not divisible by 2, so that means it cannot be divisible by. Then we have, is it divisible by 10? No, it does not end in a 0. So it's only 3. All right, so now that we know how to do that, that's the thought process we're going to do when we do the next one without having to write so much. However, speaking of writing so much, every single one of you should have written exactly what I have written up there. Yeah. Yes, ma'am.
How come there's no rule for 7, 8, and 9?
Because it isn't consistent like that. There isn't a consistency. There's not a property or a rule or a trick. You just giving up? What's up? 610. 610. Let's go, bud. 49. Is 49 divisible by 2? No. It is not divisible by 2. Is it divisible by 3? Because 4 plus 9 is 13. No. It is not divisible by 3. Is it divisible by 4? No. It's an odd number for 1. I don't know. I'm just trying to entertain myself. It's Friday. So then we got 5. It doesn't end in a 0 or 5, so it's not a 0 or 5. Is it 6? No, because it's not divisible by 2 or 3. Is it 10? No, because it doesn't end in 0. So I should just write 7 here, right? Okay? But no, what are the instructions for this section? Yeah, we have to write the rule, whether it's divisible by 2, 3, 5, 2, 3, 4, 5, or 6 or 10. It's not divisible by any of those, so I don't need to write anything. Nope, you don't need to write anything. That's fine.
I already put all of the numbers with
That's fine. That's perfectly good. Next one we have 10,505. Is it an even number? No, so it's not divisible by 2. Let's add these numbers together. We have 1 plus 0 is 1, plus 5 is 6. 11. 11 is not divisible by 3, so it's not divisible by 3. 4. Okay, it's not an even number. 5 is not divisible by 4.
5? Yes, you can.
Yes, you can with 5. So we're going to put 5 there. Yay! And 6, it is not divisible by 2 or 3, so it's not going to work. Then we don't have 10, so it's just 5 hanging out by himself. Then we have 24,640. Now, can you imagine if you guys were doing some sort of fundraiser with whatever activity you do, and you had exactly 24,640, and you're like, all right, we've got 9 people on this team, but we want to make sure that we get them. Can you imagine if you're like, yep, we can do it. How? It's like, well, we'll have to figure it out, but I know it's divisible by 9, that sort of thing. We'll see if that works. 24,604. Is it divisible by 2? Yes, it is, because that's an even number. Next one, 3. Let's find out. We got 2 plus 4, which is 6, plus 6, which is 12, plus 4, which is 16. 16, is that divisible by 3? No, it is not. Then we have 4. Is 40 divisible by 4? Yeah, 10 times. So we got 4. Then we have 6, or 5. Yes. 5. And it's not going to be 6 because we don't have divisible by 3, and you need to have both of those, and then you can be 6. And then we have 10. It is divisible by 10 because it ends in a 0. That number's got a lot of friends.
Best 3 friends.
Now, as it says here, the divisibility rule for 9 is very similar to that of the rule for 3. Can you figure this out? Okay. Who? You all right?
Yeah.
Okay. What do you think we're going to have to do? Manager, what are you going to do? Possibly add up all the digits. Let's see. Let's test that with one of them. 9 times 9 is 81. 8 plus 1 is 9. Huh. What about, let's see if, let's go 45 times 9 and see if that works that way. 9 times 4 is going to be, what is that, 36? That's not it. It does work. So we can write the divisibility rule for 9. Add all digits if sum div by 9 number is div by 9. Probably just going to photocopy one of yours. And that Bob Domerly does? Sure. Now, the definition of a monomial. The definition of a monomial. Not to be confused with your nomial, because this is monomial. That's right. Teacher jokes are the funniest. All right. The definition of a monomial is an expression you're writing is an expression that is either scoot up a little bit. A real number, a variable, or actually I'm going to put this over here. If you go over, do not go to the left of that. Or a product of both. It's either a real number, a variable, or a product of both. Real number, variable, product of both. Now here's what you're going to do next. I want you to draw without interfering with the letters. Hey, if it's going to be a distraction. I want you to draw a small square around where it says a monomial may not include addition or subtraction. Then you're going to create a little bit bigger of a square. And you're going to shade in that so you know what half of this assignment is all about, and you know where to look in your notes because you're highlighting this. Not with a highlighter, but you're highlighting it so your eyes look to that spot when you're going through your notes. Mine? Thank you. No. The class? I enjoyed drawing. I enjoyed school. I mean, you wouldn't. Can you stop making noise? I enjoyed school. You won't find a teacher who didn't enjoy school. I mean, we went to school to go back into school, and that's what we do every day. We're in school. Oh, you don't think that math teachers do all this stuff? Yeah, I do the test. Circle the terms that are monomials. Okay? Now, remember, they are variables which have letters. They are products of variables, of real numbers, or they're just real numbers. So, the main thing is these guys, monomials, do not like addition and subtraction. They don't like them. They're like, you, get out of here! Okay? That's what they're like, to add addition and subtraction. So, let's go through some of these and see. Circle the terms that are monomials. 2x, that is a variable multiplied by a real number. Is that a monomial?
Yes.
Yes, it is. 1/2, is that a monomial? Yes, it is, because there's no addition and subtraction. It's just a real number. Then we have y to the third, or y cubed, y times y times y. Yes, it is. There's no addition, there's no subtraction. Then we have x plus 5 walk through the door. Do the monomials welcome in?
No.
No, they kick him out. They kick it out, I guess, not a human. Oops, I don't know. I did that same thing last period. Sorry. There. Right there. It's actually just the cursor. Cool. And yeah. Don't worry. If that bothers you, I'll troll you more this year. Then we have negative 4b. Negative 4b.
Yes.
It's a yeah. It's a negative, not subtraction. Let's go. Then we have 3x minus 4y. Yes or no?
No.
How come? Beautiful. Then we have ab squared. Yes, it is, because there's no addition and subtraction. Now, in rest for time, actually still have to start 4-2. This, you wish. For this one here, it just identifies which is a monomial by writing yes or no and provide a word or words for explaining your answer. You can abbreviate here, okay? It shouldn't take you long to recognize what you just boxed in, if it has it or it doesn't. So I'm going to give you 2 minutes to do that. You can abbreviate the explanation, and in 1 minute's time, I'm going to write what the answers will be. So you can double check yourself. So there's no double wreck yourself. And don't forget the reasoning. This is the point where you work. Sit up. All the way. All the way. So your 3 options are product of number of variables, variable, real number, for in the definition that you wrote up top, for your reasoning.
Oh, yeah.
Did you put that to him, or did he grab it from you? Stop. Where's your answers? That doesn't follow the directions either. This, yeah, follow directions. Follow the directions. That's what you should have. Yes?
Or, like, the reason, the ones that had yes, I said those that the subtraction or addition, the ones that were real, they're like, I said that there's.
For your homework tonight, that'll be reasonable, but for purposes of me demonstrating notes, that would be a best answer what I have. Well, best would be actually wrote it out if this class was longer. Sparrow? Those half sheet marks are like ditto. Means the same thing. Shh, hey. Those double lines are like ditto. Means same thing as above. Moving right along. Footloose and fancy free. 4.2. Powers and exponents. It's okay if you're wrong. There's no punishment if you're wrong. For number 1, is 2 cubed the same as 3 squared? If you think it is, raise your hand. Okay. Thank you, people, for raising your hand and being confident about possibly being right, possibly being wrong. I appreciate that. This is a place to take those risks. Okay. It is not, actually. And I'll show you why. I'll show you why. For example, 2 to the third is 2 times 2 times 2, which equals 4 times 2, which is 8. Then, stop with the extra comments. 3 squared is equal to 3 times 3, which is 9. Okay, so 1 equals 8, the other equals 9. An exponent, which sits on the top right shoulder of either numbers or variables, that's telling you this number or this thing happens this many times. So the thing that I'm sitting on their shoulder, I'm going to make that happen however much my value is. For example, here is 5 to the 9th power, and it says write it as a product of the same factor. This is the exact wording as it will be on your homework tonight and on the test next Thursday. Thursday after next. Yeah. 2 weeks from yesterday. 2 weeks from yesterday. So we have the product of the same factor. And all that's doing is just writing it out. So since it's 5 to the 9th power, that means I need to do 5 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Write that. Make sure you have the right number of 5s, the correct number of 5s. So that is writing it out as the product of the same factor. Now it says, what is the value of 45? And I want you to write this first. Huge. Huge. Now some of you might be thinking, well, it's 45. No. No, that's multiplication. That is repetitive addition. When you're talking exponents, that's repetitive multiplication. So to put it into some perspective for you, this is what you're going to be going with. 5 times, you go down, and because of the commutative property of multiplication, I can add 2 of these guys, 2 of these guys, 2 of these guys, and bring them down. Then these 2 come together. So you're going to have 625 times 625, which equals, or times 125. And what you'll get when you do this on a calculator, there is a symbol that, no, I'm trying to figure out how I'm going to do this while I'm doing it, but I'll have to show you. It's a symbol that does this. It shows a variable with y in the exponent spot. And if you wanted to check your work somehow, some way with it, If we did 5, then we hit that symbol. I don't know why I'm telling you all that, cheaters. But it's going to be 953,125. Was your thought that much? Was it? Okay. Yeah, I like it. All right. So as I told you a minute ago, whenever you have an exponent, that is saying that I'm sitting on the shoulder of this thing, and I want that thing to happen this many times. Does that make sense? Okay. So this time, the 3 is sitting on the shoulder of x minus 2. So I need to have x minus 2 be multiplied how many times? 3, because the difference of x minus 2 cubed is x minus 2 3 times. Now let's do some evaluation. Aiden, sit up. Sit up. Manager, sit up. Everybody, sit up. Number 5, evaluate the expression. Evaluate means plug in and do the operations. We have Minnesota cubed. No, we actually have m multiplied by n cubed. So we have a question here. I'm going to go ahead and insert these in. So m is 2, n is 3. So I have 2 multiplied by 3 cubed. Now, should I multiply m and n together first and then the exponent? No? What should I do first? How do you know to do the exponent first?
Order of operations.
Beautiful. The order of operations says first you must do the parentheses and then exponents, and there aren't parentheses here. Oh, but wait. Back here we didn't do that. It's because of the variable. We didn't do that in the inside first because of a variable. We don't know what it is, so we can't do. Yeah, remember we had that same thing 2 weeks ago with the distributive property. Okay. I love bringing things together. All right. So I have 2 multiplied by 9, which is equal to 18. 2 times 9. Because 3 times 3 times 3? No. I did that wrong. Sorry. 3 times 3 times 3? 27. Which equals 3 times 3 is 9 times 27. 2 times 27, which equals 54. I was going to say, no, I didn't have 18 as a product earlier. Yeah. I messed up. I did 2 times 3 squared. Joey. Right? Fine. Next one. Now we have some parentheses. And also, 5th period got very angry about this. G isn't in there. Okay? It's just... It was probably originally in a different one, but that could happen on a test, so just got to be careful what you're doing. It says here, evaluate the expression. 3jh to the 6th power. So I'm going to rewrite that with those plugged in. 3, j is 4, h is 1. Did I skip? I skipped. Whatever, we'll go back. Nope, no. I want to have these all these examples for you. Like I said, that's why I said we had so much stuff to do. So we have 3 times 4 times 1 to the 6th. What is 1 times 1 times 1 times 1 times 1 times 1? It's just 1. The identity property. So that means we have 3 times 4 times 1, which is just going to be 12. Now with this one here, I'm going to evaluate this. I'm going to insert 2 times 3 cubed. Is there a variable there? No. So that means I can do order of operations. Get the parentheses first, which becomes 6 to the 3rd. So it's 6 times 6 times 6. 36 times 6. And I'm going to use the distributive property there. And I know that's going to be 180 plus 36, which is 216.
Yeah.
That's what I just did in my head. Now, let's see how well you were listening while you were writing. I want you to do number 8 and 9 right now. I want you to write 5 squared using an exponent. So that's going to be 5 and then the exponent sitting on the shoulder, right? 5 squared. And then also do p cubed using an exponent. Right, 5 squared and p cubed. Okay, that's plenty of time. This is what you should have. 5 with a 2 up top. And then, what? No. P with a 3 on top. How did you solve it?
Number 8.
No, it said write it. But those are what they commonly are. Stop making tapping noises with your mouth, with your pencils, whatever. Now, expanded form. Expanded form with the number 12,496. That's down here, written as 12,496. You take the 10,000, because 10,000 is written right here. You have 2,000, 2,000 is written right here. 400, 400 is written right here. 90, that's right here. And then the 6. That's expanded form without any without any exponents. You could also do it with exponents, and that same number is represented here. Whenever you're looking at standard scientific notation, what that tells you here is how many zeros. That tells you how many zeros. So I want you to write down what I just wrote down. That tells you how many zeros are being used. Yes, sir?
What's the thing on the side?
It's a 4. I'm pointing to this because that's what's being represented. I'm just trying to write a little fast so I can get this homework out to you. Okay. So for this one here is just writing out what you would do. And when you had that, you should have 605,000. Stop talking. 43. And I'm going to write down this answer so you have complete notes and also so YouTube has it. But just write it as I'm going, and then I'm going to give you guys your. Hi, it's online. You get it?
I didn't know if it's online.
Well, I don't have it up here because this is my 7th grade classroom, but yeah, that's why I wanted you to check before you come up here. It's online. Just go to my website. You don't have to print that out. You can just do this assignment on a separate sheet of paper. Okay? All right. 6th grader interrupted my class. I tell you. All right. So this one is 4 times 10 to the 5th plus, I know that's because I got interrupted by a 7th grader or 6th grader. 8 times 10 to the 4th. You're writing. Plus 1 times 10 to the 6th. Plus 6. And Yeah, you'll see the expanded form online with my notes. Have a wonderful Labor Day. You're all beautiful.